Hi everyone. Today we will discuss on the circuit which contain the two diode. Like one is forward bias condition, one is with the reverse bias condition with input. And we are going to apply the load voltage, the 5 volt at the load terminal, output terminal. So we will calculate how the diode it behaves in these circuits. So that I have to consider first I have to consider the diode with forward bias condition in this reverse bias. Here I am using the practical diode with the cutoff voltage of 0.7 volt, and I am connecting this with the uh, input voltage. For example, here we will see here, like if the D1 is, if the D1 is, we can consider D1 is conducting. If we consider D1 is conducting, the anode, the voltage at the anode should be more than the voltage at the cathode. Then only this D1 will go into conducting. So here is this D1 and D2 is practical diode. Like it's not ideal diode. It's a practical diode with cutoff voltages 0.7 volt. Okay. And voltage 0.7. So that here for this diode, due to the cutoff voltage 0.7 volt, voltage at the anode must be greater than the voltage at the cathode plus 0.7 volt. Okay. And here it is VA means V in. We are going to apply input voltage here anode. At the same time, the VK is V out. We are measuring output at VK plus 0.7 volt. Okay. Let's consider this equation. And similarly, when we are telling the D2, diode D2 is conducting, when voltage at the cathode is less than voltage at the anode, then only this diode will go into conduct. D2 will get on. Here also, this is also a practical diode with 0.7 volt the cutoff voltage, and so due to this cutoff voltage, we can call the VK must be 0.7 volt lesser than the anode. Okay. So that here Vk is the cathode. And this is a anode. Okay. So we'll call it as V in. Vk's V in must be lesser than V out minus 0.7. Okay. Now we are going to connect. This V1 to the anode of this, and here V in cathode, the reverse bias, and here it is, and we are applying the ground terminal here. And we are going to measure the output. But there is a small change here. Here we are going to connect 1 kilo ohm load, and we are going to apply 5 volt. We are going to apply 5 volt. So we will study this circuit, how the diodes will behave, and here I am going to apply DC sweep voltage. Like here V1 is apply the 10 volt, DC sweep is voltage of V1, the reference to this V1, linear changes minus 10 volt to vary from minus 10 volt to plus 10 with the increment of 50 millivolt. Okay. So what will happen in this case? See, here when we tell the T1 is on, the V in must be more than the V out plus 0.7. The initial condition V out is 5 volt because we are applying the 5 volt here. Okay, so that Vn should be greater than or equal to 5 volt plus 0.7 volt. So how much it is? 5.7 volt. When Vn is more than 5.7 volt only this D1 is going to conduct. Similarly, V in 5 volt minus 0.7. Then what will happen? 4.3 volt. And the same time the D2 should be less than, V in should be less than 0.3 volt. Then only this D2 going to conduct. Okay. So, for example, to theoretical, I consider it as a theoretical explanation. Okay. Here we are going to apply minus 10 volt plus 10 volt. Here also, when the diode is, as by considering these two equations, when 4.3 volt Vn and 5.7 volt. What it means? When the diode is getting off, when the diode is getting on between, when the diode means input voltage is less than 4.3 volt, then only the D2 get on, and more than 5.7 volt the D1 get on. In between this D1 and D2 off. Okay, in this condition D1 D2 off. When the D1 and D2 off, we are getting 5 volt, constant 5 volt here. Okay, so consider this one. We are getting constant 5 volt here. Okay, when when D2 is less than 0.3 point, how it will? Okay, we'll check it in the we'll check and confirm in the simulation. See the condition. Hope you are able to see the screen, right? Okay, I will change this. And everything will not be less. For example, write this first. See here. Whether this one. For example, if I consider this, when the V1 when it is 4.3, when it is 4.3, the output voltage is 5 volt, and when it is up to 5.7 volt, 5.7 volt, we are getting constant 5 volt. When input voltage more than 5.7 volt, the diode start conducting, because what happened here, in this case diode D1, okay, when the D1 gets start, V output is equal to V in minus 0.7 volt, because V in is equal to, here you can see here it is V in is equal to V out minus 0.7 volt. When the V D1 gets on, the V in is equal to 5 volt plus 0.7 volt, so that V out is equal to, here 5 volt, V out is the 5 volt, so V out is equal to V in minus 0.7 volt. So when we apply the input voltage as 5.8 volt, then it will become 5.1 volt, because output voltage minus 0.7 volt. Similarly, here output voltage is equal to V in plus 0.7, okay, because see here, V out is equal to V in plus 0.7. So when we apply V in is 4.2 volt, V out is equal to 4.2 minus V out plus V in, V out is equal to V in plus 0.7 volt. So when we apply 4.2 voltage, 4.3 voltage, the V out is 0.7, 4.2, 4.9. V out is equal to V in plus 0.7. On. Here we have that is the reason it is when it is 5.7 volt, V in is 5.7 volt, 5.8 volt, V out is 5.8 minus 0.7, 5.1. Similarly, V in is for example V in is 4.2 volt, so it become 4.9 volt. Okay, V out is equal to 4.9. For example, we'll see here, when V in is 5.8 volt, the V out is equal to 5 volt. V out is equal to 5.8 volt minus 0.7 volt, total equal to 5.1 volt. Okay. Similarly, it will increase when it is 5.8, 5.9. It will become 5.9 minus 5.2. 5.2 it will get. Similarly, here also. When V in is equal to 4.2 volt, the V out is equal to 4.2 volt plus 0.7 volt. So how much it is? 4.9 volt. Theoretical value and the practical value are matching. When we go to the simulation, we come to know how the diodes behaves in the circuit. Hope you understand this circuit.